Hi, everybody. This is Barry Letterman, and here we are coming to you live from Hogwarts. I do get congratulations. I was accepted to Hogwarts. Thank you. And we're beginning Palomar Math 130 calculus. So let me share my screen with you, and here we go. Okay, this is our textbook, calculus and applied approach, a brief calculus and applied approach. And it's by Ron Larson. As you can see, I have an ebook here. I don't care what you get, if it's a regular book, ebook, it doesn't matter to me. Whatever is the cheapest for you, that's fine to me. And let's see, here we go. Let's look at some of the so we're gonna jump right down here. I want to just review some of our basic what's the word I'm looking for? Just some of our basic so let's go to the Cartesian plane and the distance formula. So here we go, and this is okay. So the Cartesian plane, that's the XY, coordinates. But I'm gonna I'm leaving my face here so you could see that I'm a human being and I'm talking to you. As you know, that our class is, just to be clear, our class is going to be asynchronous until the return to campus. Our class will be asynchronous. I mean, I'm recording this. I'm going to send it out to you, and you know, so it's not during our regular class hours. Just you're going to view this when you're able to. So just like you can represent a real number by points on the number line, you can represent a pair of numbers by points on the plane. And that's something you've seen. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. The horizontal numbers are the X numbers, the vertical is the Y, 1, 2, 3, negative 1, 2, 3. And that's the coordinates. Again, I'm going through a little quickly, but it's something you've seen many, many times before. And this point up here is 3, 4, because I'm going 3 in the horizontal direction and 4 in the, and going up 4 in the vertical direction. So 3 horizontal and 4 vertical. And that's how this works. The point negative 1, 2, that's this guy right over here, because we're going backwards in the horizontal and up 2 in the vertical. 0, 0, that's that right there where the two lines meet. That's called the origin, by the way. 3.3, 0 is right on the line. That's on the what they call the x-axis. Negative 2, negative 3 is down here because we're going negative 2 horizontally and negative 3 down vertically. So that's what that's the coordinates. Alrighty, let's go into the next page. That was page 2. And again, this is section 1.1. That's what we're going to do right now. And to sketch this is what's called they call it a scatter plot. It's kind of like it's almost like graphing, but you don't have the lines. So in 2005, it was 112. So in 2005, you have 112. In 2006, which is right there, you have 114. In 2007, which is right there, you have 116, and so on and so forth. And this is called a scatter plot because you're just putting the dots down. We're not necessarily making any lines or curves or anything. It's just putting the dots down for each of these values. Now, sometimes you can make a line or a curve. You can see how these points will form kind of a line or a curve or something like that. And sometimes it'll just be kind of scattered. But it really depends. It always depends. And that's something that we like. That's something that statisticians and mathematicians like to analyze, and businesses like to analyze that. And it's a very big field. Taking like points and seeing what's the best. They call it curve fitting, the best curve that goes through certain points. Anyway, I'm going a little quickly now because this is kind of basic stuff. That is kind of a review of basic stuff, but sometimes a nice review helps. This is called a bar graph. I like to hang out in bars a lot, so that was a joke. So it's a bar graph. So here you see in 2005, there's 113. So instead of just putting a dot, I put well, that should go a little higher, actually. It should go up to 113, but whatever. In 2006, there was 18. Why are these numbers off? Unless this is the wrong numbers for this graph. It seems a little off. But instead of putting dots, you draw a bar all the way up to the point. That's a bar graph. Okay. Again, these are just different types of graphs. Now, back to the XY plane, you have something called the distance formula. Now, I never understood what this picture is about. Like it's not like it's not like the picture is explaining the math. Maybe a teacher looks happy and confident, so you're supposed to look happy and confident. I'm not sure what's the point of this. I never understood some of these pictures here. But anyway, I digress. So we know from the Pythagorean theorem, a squared plus b squared equals c squared. It's a very famous thing. We could use the Pythagorean theorem to figure out the distance between 2 points, because if you have this point up here and that point up there, well, the vertical distance is really the difference between the top point and the bottom point. And the horizontal distance is the distance between that point and that point. So this is y2 minus y1, and that distance down, that distance there is x2 minus x1. The distance between the two points, this slanty distance here is just d, the distance. Well, if I translate this in the Pythagorean theorem, I get x2 minus x1 squared plus y2 minus y1 squared, because that's a squared and b squared, equals d squared. So that gives me what's called the distance formula. If you didn't remember all that, that's fine. The bottom line is that's the distance formula. So if I have 2 points here, by the way, I'm also going a little bit faster than I would in a classroom, because since this is being recorded, you can always, if you don't catch something, you can always go back and repeat it, and you can repeat it a million times if you want. So I'm also that's another reason why I'm going kind of fast. If I was in a classroom, I'd be a little bit more repetitive and going over it more. But here, if you don't get it, you can just keep on replaying it. Anyway, the distance between these 2 points, -2, 1 and 3, 4. Well, my first point is going to be -2, 1, so that's my x1 and my y1. 3, 4 is going to be my x2 and my y2. And now I'm going to just plug it into this distance formula. So 3 minus -2 squared plus 4 minus 1 squared, because I'm getting these numbers from right here. And that's the 3 minus the -2, and that's the 4 minus the 1. I'm combining them, and then I'm going to square them. 5 squared is 25, 3 squared is 9. You add that up, you get 34. So the answer here, the distance between these 2 points, is the square root of 34, which is about 5.83. Now, if we had a ruler here, we could actually measure it to be, 5.83. So that's pretty cool and awesome. Okay, suppose you have I give you the coordinates of 3 points, and I'm asking you, do these 3 points form a right triangle? Well, I could figure that out with the distance formula, because if I figure out this distance and that distance and the other distance, and see if a squared plus b squared equals c squared, then that tells me I have a right triangle, because that only works. It only happens in right triangles. Well, the first, this is my so D1 is between the 2, 1 and the 5, 7. So y2 minus, so x2 minus x1 is 5 minus 2, then square it, and that's 7 minus 1, square it. That becomes 3 squared plus 6 squared, which is square root of 45. And D2, which is this guy down there, so these are the 2 points. So it's 4 minus 2 squared, 0 minus 1 squared, and that becomes 4 plus 1, which is 5, because that's 2 squared, that's 1 squared, -1 squared, that becomes 4 and 1, square root of 5. And finally, D3 is between these 2 points right here. So it's going to be 5 minus 4 squared, and then 7 minus 0 squared. I'm subtracting the x's, I'm subtracting the y's, squaring them. And that becomes 1, and that's 7. So 1 squared is 1, 7 squared is 49. It'll be 50. Now I want to see if I take D1 squared, D2 squared, well, that's going to be square root of 45 squared, which is plane 45. That's square root of 5 squared, which is plane 5. You add that up, you get 50. But D3 squared, square root of 50 squared is 50. So we see D1 squared plus D2 squared did indeed equal D3 squared. So we see by the distance formula, we verified this is indeed a right triangle. By the way, for those of you who know a little bit about graphing, there's another way you could have verified this is a right triangle. You could have looked at D1 and D2, and you can find the slopes. Because if these two lines are perpendicular, then the slopes will be negative reciprocals of each other. So if you compare the slopes, I'm going to let you do that as an exercise. Compare the slopes. You should find that the slopes are negative reciprocals of each other. But I'll leave that for you. Just a little hint there. Okay, so now we're going to find the length of a pass. When I say a pass, it's like in a football. So in a football game, a quarterback throws a pass from the 5-yard line, 20 yards from one sideline. Pass is caught by a wide receiver on the 45-yard line, 50 yards from the same sideline. So here he is, he's on the 5-yard line, and he's 20 feet from the side. And the guy gets it on the 45-yard line, and he's 50 feet from the side. So basically, I could say that the coordinates of this point, if you will, are 20, 5, because horizontally is 20, vertically is 5. And the coordinates of this point are 50, 45. And now I just have to do Pythagorean theorem. So I get 20 minus 50 squared, which comes out to be 900. 45 minus 50 square it comes out to be 1600. Add this up, you get 2500. The square root of 2500 is indeed 50. So he threw a 50-yard pass. Even though in the stats it'll count as it's a little unfair, sorry. In the stats it's going to count as a 30-yard pass. But in reality, he threw the ball 50 yards. So give the guy a little credit. And that's from the point of, they have this thing now in football. They didn't used to have it, but now it's been around for quite a while. YAC, yards after catch, because if the receiver, sometimes the receiver catches the ball and gets tackled right away as soon as he catches it, and sometimes the receiver catches it and then is able to run further with it. But right now, in terms of just from where he caught it, the ball traveled in the air 50 yards in the air. All right. Anyway, that's so much for my football knowledge. By the way, Bengals all the way. You heard it here first. Okay, now we have another famous formula in graphing called the midpoint formula. Midpoint formula is like this: x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So basically, I take the average of the x values and the average of the y values, and that gives me the coordinates of the midpoint. First of all, what do I mean by a midpoint? I have a line segment. I have this point here and that point there, and I want to find the point that's exactly halfway on this line. So what I do is I take the average of the -5 and the +9, and that averages out to +2, because -5 plus 9 divided by 2, that's 4 divided by 2, which is 2. And the average from -3 to +3, that's -3 plus 3, which is 0 divided by 2, that's just 0. So the point 2, 0 is exactly halfway between -3, -5, -3, and 9, 3. Alrighty. Annual revenues, that's good to know. Estimated annual revenues. So McDonald's Corporation, I don't know if you've ever heard of McDonald's. I don't know if you've ever, there actually is an actual place called McDonald's, where they sell like hamburgers and stuff like that. I don't know if you ever heard of it. So McDonald's Corporation had annual revenues of about $27 billion in 2011, and about 28 billion in 2013. Without knowing any additional information, estimate the 2012 annual revenues. So we're going to assume that the 2012 annual revenues are like sort of, it's like the midpoint of these 2 points. That's really what we're going to, now that's not necessarily true, because things don't always go in a straight. Now sometimes but we're just kind of estimating things here. So I'm going to do the midpoint formula, x1 plus x2, y. Well, the x1 and x2 are the years, 2011, 2013. You add it up, divide by 2. You get the average, which comes out to 212. No surprise there. And then I'm going from 27 billion to 28.1 billion. And that averages out to 27.55 billion. And we estimate that in 2012, the revenues were about 27.5 billion already. And let's move on. Okay, translating means sort of sliding or moving. So translating points in a plane. What does that mean? What does that mean? And how do we do that? And we have Spider-Man, so that's kind of cool. It's always nice to have Spider-Man here. Why we have Spider-Man, I don't know, but that's what we have. So here we see a parallelogram, and these are the vertices, these points right here. And we're going to translate it. Translate means we're going to slide it, we're going to move it. What does it say here? Where is it here? 4 units to the right and 2 units down. So we're going to add +4 to each x value and subtract 2 from each, or add -2, if you will, to each y value. So 1, 0 becomes 1 plus 4 and 0 minus 2. 3, 2 becomes 3 plus 4 and 2 minus 2, and so on and so forth. This next one becomes 3 plus 4 and then 6 minus 2, 1 plus 4, 4 minus 2. That becomes 5, -2, 7, 0. This is the new points. And to just show what it's going to look like, this was the original parallelogram. And then when I moved it 4 to the right and 2 down, it wound up over there. So notice that the shape, like these two parallelograms are congruent. They're exactly the same size and shape and everything. I just slid it. Translating means I don't change the shape in any way. I just slide it, whatever, I just couldn't slide it. That's translating. Okay. Blah, blah, blah. Summarize. This is interesting. You summarize, going back here. And I don't know if you guys will get this because you live in San Diego, but you summarize a lesson, but you winterize your car. When you drive, this thing's called winterizing. Okay, so here's some homework problems. So for homework, I want you to do all the ones that are red. So I want you to number 1, number 3, number 13, number 17, and number 20. Let me just pause for a second. Anyway, so the questions that you're going to do for 1.1, you just click right here, and here's the question. So it's number 1, 3, 13, 17, 21, 25, and 35. I think all of these were red except for 25. So that's what was that? 25 did not have red, but the rest of them all had red. I think 35, yeah, 35 has red. Oh, actually, I wanted to do 37 also, so I'm gonna add that in. Let's add in 37. All right, so that's your that is your homework for this section. Okay, everybody, it should be loads of fun. So you had that, you had yeah, you're all good. 25, and you had yeah, 1, 3, 13, 17, and 21. Yeah, we're all good. Okay, everybody, that's it for this one, and that's it for this section. We'll see you guys next time. Bye.